All right. Focus. Today we are going to start. Today we are going to start with function notation, which is another name for y. So function notation equations that are functions can be written with an f of x or any other letter rather than y. So it could be, this is red, f of x, by the way. Not f times x, that's f of x. So it's important that you understand that that is not multiplication at all. This is not multiplication at all. That's not multiplication. Be very careful not to start thinking that they're two separate pieces. F of x is one thing together, and it stays together, okay? And that's something that gets confusing because some of you guys are going to want to do additional dividing and stuff later. So another name for y. Again, it could be any letter. So this equation is y equals 3x minus 8. It could be written as a function as f of x equals 3x minus 8. We could use g. It could have said g of x equals 3x minus 8. So why do we do this? Well, sometimes you're going to be graphing more than one line on a graph. Examples, the EOC might want that. Systems might have that. It's important that you name them different names. If you're only using y, it's very hard to tell the difference between the two lines. But if you're using f of x and g of x and h of x and m of x and whatever of x, you can literally take that line and put f of x on the end of it, and then take another line and put g of x on the end of it, and you can tell the difference between the two lines then. So that's one way we do it. Also, it shows the relationship between the input and the output, so the x value and the y value, or the x value and the f of x value. We know if we input something in, something's going to come out. That is what a function is telling us, and that's what function notation represents. So in a function, x represents the elements of the domain, and f of x represents the elements of the range. That's because f of x is the same thing as y. So since it's the same as y, and y means range, that makes sense that that would be the same. So example, suppose you want to find the values in the range that correspond to the element of 5 in the domain. This is written as f of 5. X is always your input, and it is inside. I spelled input wrong. So input and inside both start with in. Do you guys see that? So you know X is your input. The one that's inside of the parentheses is your input, which is X. X corresponds to input. They both have in them. And is read as f of 5. The value of f of 5 is found by substituting 5 for x in the equation. So this would be just like this. So for example, if we're using that f of x equals 3x minus 8 up there, if we did f of 5, do you see how we replaced x with 5? So wherever we see an x over here, we replace it with 5. So that's 15 minus 8, which is 7. This was no different than when you guys were learning this stuff at the beginning, like when you were younger. When somebody told you that x was 5 and you were given the equation y equals 3x minus 8, you knew that you could plug 5 in for x, right? That is no different than what we're doing today. It's just written differently, which can be sometimes confusing for you guys because it's not written the same way as what you're used to. Okay, so before we get into examples, I want to talk to you guys about a few things here first. Let's think about a function as a machine. Let's think of a function as a machine. Please stop. A coffee pot is a machine, right? If you input coffee grounds, what comes out? Coffee, like if you put water and all that other stuff in. But the point being is it comes out as something different. So we're going to use this input-output relationship. If we input a number for x, we're going to get an output of a y or an f of x, depending on how you want to look at it. They're the same thing. So that's the kind of relationship we are looking at today. So let's do some examples. So here are your two equations up here. So notice that there's two different equations up here. One is named by F and one is named by G. So if it says F, you can only plug into F. If it says G, you can only plug in for G. All right? That's another reason why it's nice to have function notation with the letters. If you just had Y's up there, you would think that you had to plug them in for all of them, but you don't have to do that. So since -2 is on the inside, so see this is in the inside, it is an input, and inputs correspond to x, so we're saying x equals -2 in the function named f. It's actually not that, it's not that hard, it really isn't. Once you guys get used to the notation, it's not that bad. It's just getting used to something different. So we replace x with -2. So let's start with this. F of x is 2x plus 5, right? That's given to us up here. Do you guys agree?
Yep.
Okay, so if we replace that with f of -2, then what does the other side become? Jordan? Yep. And then you just simplify that. So when you input -2, your output is, what's your output? What did we get out? When we input at -2, what did we get out?
1.
Yeah, we got out 1. It's just like when you input coffee grounds to a coffee pot, you output coffee. It's that same kind of concept. In this case, this is an ordered pair. Not all cases are an ordered pair. Your ordered pair in this case would be -2, 1, but I'm not going to write them as an ordered pair because that's going to get confusing because you don't always do that. All right, is this inside or outside of the parentheses? Is 1/2 inside or outside of the parentheses? Inside, which means that it is an input, which means that x is equal to 1/2 in the function named f. You okay? If you need to go to the nursery, then just let me know. So f of x equals 2x plus 5. But we're replacing x with 1/2. So what does the other side of the equation become then? Colin, what do you think the other side of the equation is going to become then? So in this case, it was replaced with -2, so we replaced wherever we saw an x with -2. In this case, x is being replaced with 1/2, so what is it going to become?
Oh, it's 2 1/2. Yeah, 2 1/2 plus 5.
2 times 1/2 plus 5. So if you input 1/2, your output is 6. So as an ordered pair, that would be 1/2 comma 6, but we're not going to do it that way because, like I said, not all situations end up in an ordered pair, like the next example. So what do you guys think we're going to do in C? What do you guys think that we're going to do in C? What are we thinking? What do you mean by do both of them? What does that even mean? Use detail.
I think I know how to do it. Yeah.
Justin, Justin.
Justin, what are you thinking?
Well, you're gonna figure out what G is and then figure out what F is and then you add them together for your answer.
Good, so figure out what G of 1 is.
But I think I know it.
Then figure out f of 7 and add them together. So you're going to figure out what g of 1 is, then figure out what f of 7 is, and then you're going to add the two of them together. That's what that means. So if there was a subtraction sign in between there, you would have subtract them. If they were a multiplication sign between them, you would multiply them. If it was a division sign, you would divide them. But you first figure out each of them separately. So notice that g of 1 is with g. And g is the same thing as x squared minus 2x. And we know f of x is 2x plus 5. Okay, let's start with g. Alyssa, if I'm doing g of 1, what does the right side of the equation look like then? So, is this an input or an output? I guess that's the first question. Is 1 inside or outside? So it's an input, right? So that means x equals 1. So what are we going to do here then? Look at these ones over here. See what we did? So when it was 1/2, we plugged in 1/2 wherever there was a x. So what are we going to do here? Wherever there's a. So what is that going to look like?
1 second power minus 1 or 2.
What is x?
1.
So wherever we see an x, we're substituting a 1. Notice I use parentheses. Parentheses are your best friend. Use them. What squared following order of operations is, remember, exponents comes before multiplication, division, or addition, subtraction. So 1 minus 2, which is negative 1. Okay, Kaylee, if I do f of 7, what does that mean for the right side?
2 times 7 plus 1.
Perfect. So what do we still need to do with negative 1 and 19, Justin? We still need to use this addition sign here. So we're going to do negative 1 plus 19, which is 18. So what this is saying is if you take the output of g of 1 and take the output of f of 7 and add them together, you would get 18. So the sum of those outputs are 18. Do you need a pencil? Take one out and start writing, please. Okay, another confusing one. This is called a composition of functions. So this is called a composition of functions. And to do a composition of functions, notice one is inside of the other. You guys see that? You start on the inside. So you start with the inside function. Yeah.
Can you just use the top answer?
For g of 1? Yes, we will be able to do that. But it's not 18, it's just g of 1 that you can use. I'm just going through the process of how you would do it first. So you start with the inside function. And then from the inside function, you get an output. Use the output of the inside function as the input of the outside function. So we'll put this into play here in a second. So use the output of the inside function as the input of the outside function. Yes? Greg, I just called you Greg, Riley. You know, what are you going to do? Riley was correct by saying we already know what g of 1 is. We found it above. So I am still going to repeat the process just so you guys have it in your notes. So we know that g of x is the same thing as x squared minus 2x. So we said g of 1 means you're inputting 1 everywhere, that there is an x. And we found that as 1 minus 2 equals negative 1, right? Didn't we do that up here? Do you guys see how we did that up here? So Riley was correct by saying, really, do I need to do that work? No, not necessarily, but for your notes, I would have it written down so you know where we got things from. So we are saying that g of 1 is the same thing as negative 1. So we're taking g of 1 and we're replacing it with negative 1, and we're going to now find f of negative 1. So f of negative 1 is using the f of x function. So we'll do that in f of x. So we get negative 2 plus 5, which is... So notice, there's two answers here. Are both of them your answer?
No.
No, but that's what you guys like to do. So that's why I asked that question, because this is new to you guys. So you see two answers, so you want to circle both of them, right? What is your final answer? What is the final answer you got? Lexi?
3.
3. So you only circle your final answer. Okay, what questions do you guys have so far? Okay, get that written down, and then when I see that you guys are all ready, I will move on to the next examples. All right. Okay, what is different about A on this side? What is different about A on this slide? Colin?
It's like, the X is supposed to be a number. I don't know how to explain it.
So the X isn't a number in this one, right? What is it different here?
Solving for y instead of x.
You know what Y is.
We don't know x.
You don't know what X is. So notice this is outside of the parentheses. Do you guys see that? It's outside of the parentheses. Do you guys see that? Where before they were all inside. So outside and output start with out, right? And output corresponds to Y's. Remember, f of x is the same thing as y. So this is saying y is equal to 6. So we're going to use this here. So instead of solving for f of x this time, we are solving for x. So this means you're going to solve for x. You know y. So you're solving for x. You know your y. Okay, so f of x equals 2x plus 5. But we just said that f of x is the same thing as 6. Do you see how those are all highlighted in purple? So we can replace f of x with 6. And then we will solve for x. So it's a little bit different. So you have to ask yourself, is it inside of the parentheses or outside of the parentheses? If it's inside, it's an input, which means it goes in for x. If it's outside of the parentheses, it's an output, which means it goes in for y, and f of x and y are the same thing. So then you just solve this. So x is equal to 1/2. You just decided that 6 months
Connor.
was a negative.
Connor.
Although thanks to Riley.
All right. What do you guys think that B is saying for you to do? What do you guys think B is saying for you guys to do? Raise your hand and tell me what you guys think B is saying. Jana? Yeah, add 4 to the output what you guys would consider your answer of f of 1. So you're going to find f of 1 first, and then add 4. So, is this the input or the output? Is 1 inside or outside? It's in, so it's input. So x equals 1 is what that's saying. So I'm going to go to f of x, which is 2x plus 5. My equations are up here again. They won't always be those two equations, by the way. You'll have different ones on your homework, by the way. So we do f of 1. Connor, what goes on the right side of f of 1 then?
Oh, wait. 1 plus 5.
2 times 1 plus 5. So that's 2 plus 5, which is, but it's okay. And then Mike, what do I still need to do? Mike, what do I still need to do?
You need to. Oh, add 4.
So we take the 4 and we add it and we get 11. Brian, after you're done writing B, tell me what we're going to do with C. What do you think we're going to do there, Brian, and C? Look at C from the previous slide and see what we did there and see if you can figure out what we're going to do on C on this slide. What do you think we'll do?
Change the 2 to an x. And
But what did we do? We found G of
1,
and F of?
2,
No?
1.
What's there? We found F of G of 1 and F of 7 separately, and then what did we do with those two pieces? Okay, you got F of G of 1, F of 7. What did we do with those two pieces?
Added them.
Because there was a,
Equals 1.
no, that's an addition sign.
Addition sign.
So what do you think you're going to do here? Find,
Find G of 2
And.
F of 4.
and then what are you going to do with those answers?
Subtract.
There you go. So you're going to find, this is why I write all this stuff off to the side, guys. This isn't for me. If you look on the previous slide, I don't see a lot of you having all this random writing I have on there. I know how to do this, okay? You guys should write it down so you have something to follow when you go to use your notes. I don't do that for me. I do it for you. So find G of 2 and F of 4 and subtract the outputs. If you do not know what you're doing, you should especially be the one to write this down. So this one's a g of x one, so g of x is equal to x squared minus 2x. So RC, what would I do to find g of 2?
You would put parentheses takes 2 squared minus 2 in parentheses 2.
Perfect. So exponents first. So I get 0 there. Miguel, how would I find f of 4 if f of x is equal to 2x plus 5? So how would I find f of 4? What would I do?
Times 2 4 by 2
And then,
at 5.
good, 2 times 4 plus 5. So what are we going to have to do still with those two pieces? Riley?
Subtract them.
So we still need to use this subtraction sign. So 0 minus 13 equals negative 13. All right, D is very, very similar to A over here. So we're going to say this is very similar. So I'm going to write that here. So we're going to find G of 2 first and then add 7. Go ahead, Jordan. Yeah, so again, much like the previous problem, isn't G of 2 0? Yeah, but we're going to show our work because it's notes and it's good for you guys to look back at it. But yes, you could. You know the answer is 7. But we're going to plug in 2. So that's 0, right? So 0 plus 7 is 7. All right. Look at that and see what questions you have before we get on to the next page. Don't worry, the equation's actually changed on the next page.
Bless you.
All right. So notice we have different equations this time, so make sure you're not plugging into the same ones. Okay, you have to ask yourself, in A there, Emma, is that an input or an output for A? It's inside the parentheses? No, it's outside the parentheses, right? So outside means an output. So you're trying to find x. So output means that you are finding x. So we have f of x equals negative 2x plus 5. Well, notice f of x is the same thing as 17, and there's an f of x here, right? So we can replace f of x with 17 because they're the same. That's using substitution there. So we're just replacing that there, and then you just solve it. If you went ahead, just make sure you're checking that your answers match mine when you're done. If you went ahead, just make sure your answers are checking mine when you're done. If they do not, make sure you make corrections or ask questions why you did it wrong. Yeah. Do you want a clipboard or anything? Do I have one maybe? I should, but I don't think I do. I think they're all somewhere else from cross country. Sorry. I don't have a clipboard anymore. I think they're like in my car or something from cross country. All right. This is a composition. So inside first, answer goes into the outside. So we'll do f of 1 first. Is 1 an input? Is 1 an input or an output? Is 1 an input or an output? Input, it's inside, so you know x, you're finding y. So it's an input, so it goes in for X. So that's 3. Are we done with the problem? No, what do I still have to do, Jayla? What do we plug in for G? Yeah, so now we say f of 1 is the same thing as 3. So now we are going to do g of 3. So g of x equals 3x plus 12. So g of 3 is 3 times 3 plus 12. Hey, at least he's doing his work. That's all I care about. Okay, so what is our answer here, Blaine? What is my answer here, Blaine?
21.
21. That 3 is just there as part of the process. It's not our final answer. It is a step in the way to get to our answer. Okay. Grace. In C, is that an input or an output? Output. It is outside, so it is an output. So we are trying to find X. So g of x equals 3x plus 12. Well, g of x is the same thing as 12, and there's a g of x here. So I can replace g of x with 12, because they are the same. So x equals 0. And then finally, this one just means take your answer and subtract 9. So is 2 inside or outside? Is that an input or an output? Tenari, is for D, is 2 an input or an output? It's input, so that means x equals 2. And then all we have to do is take that and subtract 9 and get 9. Okay, before we get into some contextual examples, let me know what questions you guys have so far. Before we get into context, let me know what questions you have so far. Where are you confused? Do you understand the difference between being an input and an output? Do you understand what to do different in those two situations? Do you guys understand how to do compositions? Okay? Do you know how to read problems when they aren't just one thing? Okay? Do we have any questions on that stuff? Question? Okay, let's look at the next example here. Find the value of the values from the graph. So you're studying English in a training center which charges a $100 registration fee plus $15 per lesson. Find the answers to the following questions. So first of all, f of 10, is that an input or an output? Input. That means x equals 10. So what you're going to do is you're going to find 10 on the x-axis. So 10 is right here on the x-axis, right? If I follow that up, Mike,
250.
you get over to the y at 250. Perfect. And now we're going to explain the meaning and context. What does 10, 250 mean? What does 10, 250 mean? So let's label our graph. What does the x-axis mean? Riley, what is the x-axis?
The X is the The lessons.
Yeah, it's price per lesson, right? And in slope, you guys know slope is a change in y over a change in x. You guys learned that last year, correct? So x is our lessons. So what would y be? A cost. So what does 10 to 50 mean? After 10 lessons, you've spent $250 on your lessons, right? So after 10 lessons, you have spent $250. Colin, is this input or output?
Alright, that is output.
So that means that y is 100. So we go to the y-axis and find the number 100. And we find the x-coordinate that corresponds to it. What x-coordinate corresponds to that? Jayla? 0. So what does that even mean? Yeah. Yeah, the initial cost at the center is $100. So 0 is like the initial. So the initial cost is $100 before you take a lesson. When you're ready, go ahead and flip.
No.
Jordan's out right now, so just wait.
Okay.
All right. Find each of the values from the table and then interpret the meaning. So the X is the boy's age and Y, or H of A, sorry, this is A. So this is like input, output, sorry. So the input is A, H of A is the output, and the average height in inches is the output. Okay, so Emma, is 9 in A input or output? So this is saying A, the age equals 9. So where in this chart, what is the height when the age is 9, Emma? So RC, what does that mean then? At 9 years, a boy's average height is 53 inches. Mike, is 61 an input or an output? So that is Y equals 61 essentially, or H of A equals 61. Where is it 61, Mike? At what age?
13.
So Connor, what does that mean?
That the average height of a 13-year-old boy is 61 inches.
You can go. Okay, questions so far? All right, last one. Alyssa, is 178 the input or the output? Input, so that means X is 178. Yeah, the graph is pretty terrible. So 178 is right here. You have to follow it up to the line, not to the dot. So this says the height in feet, and this is the shoe size, I think.
That's terrible.
And that's, so this is 6, 7, 8, 9, 10, 11, 12, 13, 14.
It literally looks like a cool.
So that would be about 11. So Justin, what were you saying that would mean? You said the sentence. What would it mean? And then lastly, is 13 an input or an output? Output. So 13's way up here. We follow it. Don't stop at that point there. Go all the way to the line. This is a scatter plot. We will be doing these at the end of the second part of this unit. And they're going to be really important for your EOC. And you did them last year, and you do them in science as well. So hopefully you guys will be fine by the time the EOC happens. Okay, so I think that says 184. If your shoe size is 13,
How tall is 187?
your height would be, 1 second, 184 centimeters.